How to graph lines in any of 5 forms. This is Tom Reardon, math teacher from Ohio. You will need graph paper and a pencil. Please press pause anytime as needed. If you don't have graph paper, you can download this PDF at this website, which can be printed with 20 grids on each side. Equations of lines occur in several forms. We're going to look at 5 different forms that could happen. First one is y equals some constant. Examples would be these. Notice there's no x in the equation. So for our example, we're going to graph y equals 3, which you may know how to do, but I'm just going to review real quickly how you would do that. Making a table, we'll just go with 5 values. And y is, well, go ahead and complete the table. Pause is needed. And surprise, surprise, y is always 3. That's it. That's what it says right here. Y equals 3. So plotting those, 2, 3, 1, 3, 0, 3, negative 1, 3, negative 2, 3. When you connect the points, you definitely get a line. We said these would be lines. And some terminology about the line. It is a linear function. It passes the vertical line test. It's called the constant function. Y is constantly the same number, in this case 3. It's a horizontal line. And the slope of this line is 0. So this is some information about the graph of y equals c. Second, x equals a constant. I use a different letter just to emphasize constant. Examples here. Notice again, no y variable in any of these equations. So the graph for x equals negative 2, again, we would start by just reviewing this in case you need to, making a table. And oops, I can't put in those values for x. And the reason for that, it says that x is always negative 2. So in my table, x has to be negative 2 all the time. But y could be any number. So I'll use those numbers from those that I use for x. It can be any number. X has to be negative 2. That's the only qualification in this equation. So go ahead and plotting those points. Negative 2, 2, negative 2, 1, negative 2, 0, and x-intercept, and so on. Definitely trace out a line. Surprise, surprise, we said these were lines. So we'll connect the points, and there's our graph of x equals negative 2. Some terminology here. It is a vertical line. It is not a function, because when we put in a value for x, we get different values for y. That is not how a function behaves. The line has no slope, or sometimes we say the slope is undefined. Third, y equals an equation in the form y equals mx plus b, m times x plus b. This is called the slope y-intercept method. So examples of equations in that form would be these. The example we're going to do is y equals negative 2/3 x plus 1. So what we'd expect you to do is write the equation right below it, y equals m times x plus b. And we like to identify the y-intercept first. We go in alphabetical order, b, then m. And so b turns out to be positive 1. The slope, in this case, turns out to be negative 2/3. And so we graph b first. So let's go ahead and put in our graphing grid. And we're going to graph b as a y-intercept first, and that's going to be at 0, 1. From there, we use the slope here to find 2 more points. Negative 2 over 3 is the slope, change in y over change in x. So negative 2/3 would mean down 2 and to the right 3. And there's another point on our line. And again, change in y is down 2, change in x is positive 3. And there's another point on our line. Technically, we only needed 2, but we always like to get at least 3. And so now we'll connect those points. And there's a graph of the line using the slope-intercept method. Fourth one, point slope form, is of this form: y minus y1 equals the slope times the quantity, x minus x1. Here are some examples that are in point slope form. In the example we're going to graph is y plus 3 is equal to negative 2 times the quantity of x minus 1. So I'll write the generic equation right below it, and I can identify x1 comma y1. X1 is going to be positive 1 right here because we're subtracting a positive 1. But y1 is going to be negative 3 because we're subtracting a negative 3 is like adding a positive 3. So be aware of that. So that's our point that is on the line. We'll plot that point, 1 comma negative 3. And then we'll identify the slope as negative 2, which is negative 2 over 1, change in y over change in x. And again, we're going to plot 2 more points using this slope. So from that point, I'm going to go down 2 to the right 1. So that's a slope of negative 2 over 1. And I'll do it again. Down 2, right 1. There's my third point. So we'll connect those points into a line, and that's the graph using the point slope form. Terminology for this, it's pretty much a linear function. And the point that it goes through has coordinates x1 comma y1. Again, it has to be written as a subtraction here. All right, the final one, standard form, an equation in standard form. Some examples would include these 3 here. How would we graph an equation in standard form? We could rewrite it as slope-intercept form, but we're not going to. We're going to use the x-intercepts and y-intercepts. And recall that an x-intercept occurs when y is 0. If it's going to be on the x-axis, the y-coordinate is 0. So we're going to go ahead and substitute y equals 0 into this equation. So it'll be 3x minus 2 times 0 equals 12. That's going to leave me with 3x equals 12. And dividing both sides by 3, x equals 4. So one ordered pair on this line is 4 comma 0. This is the x-intercept where it crosses the x-axis. So graphing that point 4 comma 0 on the x-axis, there it is. That's one of our points. The y-intercept occurs when x is 0. Anything on the y-axis, the x-coordinate is 0. So again, we will substitute 0 in for x into this equation. And 3 times 0 minus 2y equals 12. This, of course, is 0. Negative 2y equals 12. Divide by negative 2, and y is negative 6. So our ordered pair, 0, negative 6. And of course, we should graph that on the y-axis, 0, negative 6. There it is. So we'll connect the points because remember that 2 points do determine a unique line. And there's our graph. 3x minus 2y equals 12. Terminology, it's a linear function. So we encourage you to interact with another video from this series.